Hey y'all, today is April 13th and we are doing a little mini lesson on angle relationships. So let's get started with some important vocabulary first. Starting with adjacent angles. Adjacent angles are next to each other. They share a common side and a common vertex. And a vertex is simply a corner point. So they have a corner point that is in common. So let's look at this example right here. I know that this angle that measures 22 degrees is adjacent or next to this angle right here that measures 39 degrees. Their common vertex or corner point is that right there where B is. And their common side is this line segment right here. So adjacent angles have to have those things in common. Now let's talk about vertical angles. Vertical angles are opposite each other when two lines cross. In other words, they are across from each other. Vertical angles are always equal or congruent or equivalent. All of those words mean the same thing. So they have the same angle measure. So let's look at this little diagram right here. I know that this angle that measures A degrees is across from this angle that measures B degrees. And because they are directly across from each other, they are vertical angles. And that means that they are the same angle measure. So for example, if angle A measured 70 degrees, I know that angle B would also measure 70 degrees. Okay, moving on to complementary angles. Complementary angles add up to 90 degrees. Together, they form a right angle, and they do not have to be together. In other words, they do not have to be adjacent. So in this diagram right here, I do have two angles that are adjacent. This first one measures 40 degrees, and it is adjacent to this one that measures 50 degrees. Because 40 plus 50 equals 90, I know that they form a right angle and they are complementary. I can also tell that they form a right angle because that box will always indicate a right angle. It always indicates an angle that adds up to 90 degrees. Okay, now remember, these were adjacent angles. They shared that common vertex and they also shared this common side right here. But complementary angles don't have to be adjacent. So here I have two independent angles that together add up to 90 degrees. So they are also complementary angles. Okay. Last vocab term, supplementary angles. Supplementary angles add up to 180 degrees. Together they form a straight angle, which just looks like a straight line. They do not have to be together. In other words, they don't have to be adjacent. So for example, I've got two independent angles right here. Here's my first one that measures 60 degrees. Here's my second one that measures 120 degrees. I know that 60 plus 120 is 180, so together they are supplementary, but they are not adjacent. Supplementary angles can be adjacent, however. So here I've got a 40-degree angle, and it's right next to a 140 degree angle. So I know that 40 plus 140 equals 180, and I can recognize that visually because together they make that straight line right there. Now remember, these were adjacent because they shared that common vertex and this common side right there. Okay, now that we've gone over that vocab, let's practice using that vocab by classifying each pair of angles using all names that apply. So in number one, angle 1 and angle 2, they're adjacent. I know that because they share a common vertex or corner point right there and a common side right there. So adjacent is the first way I'm going to describe these. Now the second way I can describe them is that they add up to 90 degrees. And I know that because that box tells me that together they form a right angle. So they are complementary. They add up to 90 degrees when together. Okay, number 2. So I've got two angles that are right next to each other. I recognize that there's a common vertex or corner point and a common side. So these are adjacent angles. Now, do they form a right angle? No. Do they form a straight angle? No. So I can't classify them as complementary or supplementary. All I can say is that they are adjacent. Number 3. So we're concerned about angle 1 right here and angle 2 right here. And what I notice about those two angles is that they are adjacent. There's my corner point, and there is my common side. So these are adjacent angles. And I also can see visually that together they make that straight line right there. Because they make that straight line and form a straight angle, I know that together they would add up to 180 degrees. So that means that they are supplementary. Okay, now on number 4, I'm concerned about this angle here and this angle here. And what I notice is that they are directly across from each other. Angles that are directly across from each other are called vertical angles. I do know that they are congruent or equal in measure, but I don't have to say that here. Now number 5 and 6, I've got 2 independent angles. So I know they're not going to be adjacent or vertical, but I can still classify them. So I want to know what these two add up to. So 116 plus 64, when I add that together, I get 180 degrees. So because they add up to 180 degrees, I know that these two angles are supplementary. So remember, supplementary angles don't have to be adjacent. Okay, number 6 is kind of the same thing. 2 independent angles. One is 23 degrees, one is 67 degrees. 23 plus 67, when I add that together, I get 90 degrees. So together, these are complementary angles. Okay, moving on. So for numbers 7 through 13, we're going to find each missing angle measure. And for numbers 14 through 17, we're going to find the value of x. So let's start with number 7. So right here, and I don't have it numbered right here, but hopefully you have it numbered on your paper if you have paper. So I want to know what the value of that angle is. And I see it's adjacent with this angle that's 94 degrees, right? So together they make a straight line, so I know they add up to 180 degrees. So x plus 94 equals 180. That's a simple one-step equation. To solve, I need to get x by itself, so I'm going to subtract 94 on both sides. So x equals 180 minus 94 is 86 degrees. Okay, number 8 is this one right here. So I want to know what is the value of x right here. What I notice is that these two adjacent angles do add up to 90 degrees. So I can write an equation as x plus 23 equals 90 degrees. Simple one-step equation. I'm trying to get x by itself, so I'm going to subtract 23 on both sides. So x equals 90 minus 23, which is 67 degrees. Okay, number 3. If angle 1 and angle 2 are vertical angles, and measure of angle 2 is 112 degrees, find the measure of angle 1. Well, start with your vocab. Vertical angles means that they are equal. So I know that angle 1 equals angle 2, okay? I'm also told that measure of angle 2 is 112 degrees, so I can replace that angle 2 with 112. So angle 1 equals 112 degrees, and we're asked to find the measure of angle 1. We just did. So that is my answer. Okay, number 4. I've got 2 adjacent angles, and I see that they both make a right angle when they're together. So I know they make a right angle when they're together because that little square tells me that together they add up to 90 degrees. So we can write a simple equation. 20 plus x equals 90. I'm just adding my 2 angle measures together. So to solve this one-step equation, I need to get x by itself, so I'm going to subtract 20 on both sides. My 20s cancel out, x is by itself. 90 minus 20 is 70 degrees, so x equals 70 degrees. Okay, number 11. If angle A and angle B are supplementary angles, and the measure of angle A is 89 degrees, find the measure of angle B. We'll start with your vocab. So I know that they are supplementary angles. That means they add up to 180 degrees. So angle A plus angle B equals 180. Now, I also know that angle A is 89 degrees. So I'm going to replace that with 89. So we have 89 plus angle B equals 180. Now, I could rewrite this so it is 89 plus x equals 180, but just know that we are trying to solve for that right there. We're going to pretend like that's our variable. So I'm not going to rewrite it. It's still a one-step equation. To get angle B by itself, I'm going to subtract 89 on both sides. So angle B equals 180 minus 89, which is 91 degrees. Okay, number 12. I know that these are two adjacent angles, and I'm trying to find the value of this angle measure right here. So what I notice is that the two adjacent angles together form this straight line. So I know that they add up to 180 degrees. So I'm just going to write a simple equation, x plus 51 equals 180 degrees. To solve this equation, I'm trying to get x by itself. So I'm going to subtract 51 on both sides. So 51 cancels out, x comes down, 180 minus 51. When I put that in my calculator, I get 129 degrees. Okay, number 13. If angle M and angle N are complementary angles and measure of angle M is 6 degrees, find the measure of angle N. Well, start with your vocab. They're complementary angles, so I know they add up to 90 degrees. So angle M plus angle N equals 90 degrees. I also know that measure of angle M is 6 degrees. So I'm going to replace that with a 6. So 6 plus angle N equals 90. Now to get that angle N by itself, I'm just going to subtract 6 on both sides. My 6's cancel out. So angle N equals 84 degrees. Okay, so now we're going to move on to a little bit more complicated problems. They're not much harder, but what I notice in 14 through 17 is that I have expressions with variables. So I'm still having to identify what type of angles I have and set them up appropriately. So in number 14, I'm talking about this angle here, that is 114 degrees. And I'm talking about this angle here, that is 7x plus 23 degrees. Now notice they are directly across from each other. Angles that are directly across from each other are called vertical angles. So I want to set them equal to each other. So 114 equals 7x plus 23. Now this is a two-step equation that I know how to solve. My goal is to get x by itself. So I have to undo the thing farther away from the x first. So I'm going to subtract 23 on both sides. My 23's cancel out and I bring down 7x. And that equals 114 minus 23, which is 91. So 7x equals 91, or 91 equals 7x. Now to get that x by itself, we want to divide by 7 on both sides. So my 7's cancel out, x is by itself, 91 divided by 7 is 13. So x equals 13. Okay, moving on to number 15. So these two adjacent angles are also complementary. I know that because this box tells me that together they add up to 90 degrees. So I'm going to add them and set them equal to 90 degrees. So my first angle that I see this one first, which is 24 degrees. So 24 plus, I see this one second, 5x minus 4 equals 90 degrees. Now here I do have some like terms that I need to combine before I can solve for x. 24 and negative 4 are like terms. 24 minus 4 is simply 20. So 20 plus 5x equals 90. That's a normal two-step equation that you know how to solve. We're trying to get that x by itself. So I need to undo this 20 first. Well, what kind of 20 is that? It's a positive 20. So we are going to subtract 20 on both sides. 20 cancels out, 5x comes down, and 5x equals 70. Now to get that x by itself, divide by 5 on both sides. So x equals 14. And that's my answer. Okay, last two. Number 16 is right here. What I notice about these two angles, they are adjacent, but together they make that straight line right there, which my teacher magic tool doesn't want to make. That straight line, right? So I know that because they make a straight line, together they add up to 180 degrees. So the angle that I see first is this one right here, which is 133 degrees. So, oops, let's change that back to a pen. 133 plus my second angle, that one right there, which is 5x minus 8 degrees, equals 180. Now, I do have some like terms that I need to combine. 133 minus 8, I have to combine first. And when I combine that, I get 125 plus 5x equals 180. Now, that's a normal two-step equation that we know how to solve. To solve it, we're going to subtract 125 on both sides. 125 cancels out. 5x comes down. And 180 minus 125 is 55. To get that x by itself, divide by 5 on both sides. So x equals 11. Okay, last one right here. Now, these are kind of tricky, but the first angle that I'm looking at is this one here. And notice my arrow points this way. So that angle actually measures 5x minus 22. Okay? The second angle is this angle right here. And there's an arrow pointing to that angle, which measures 3x plus 2. So hopefully you see these and think, oh, they're directly across from each other. What kind of angles are those? They're vertical angles. So I know that they are equal to each other. So 5x minus 22 equals 3x plus 2. To solve this, I need to get all my x's on the same side. So I'm going to move my 3x right here. Well, that's a positive 3x, so to move it, I need to subtract 3x on both sides. So my 3x's cancel out, 2 comes down, and on the other side, 5x minus 3x is 2x, and I bring down negative 22. Now this is a normal two-step equation. To solve it, I'm going to add 22 to both sides. My 22's cancel out, 2x equals 24. To get x by itself, divide by 2 on both sides, so x equals 12. That is the end of this mini lesson. I hope you found it helpful.